All right, guys, this is Saxon Algebra 2. We're in lesson 18. We're going to be talking about ratio word problems and similar triangles. They put these two together and it doesn't seem like a good fit to put together, but they put the two together because we can use some of the principles of ratios with similar triangles. We'll get there in just a minute. We're going to start off with defining kind of what a ratio is, or we would call maybe a proportion, but it's how two numbers relate to each other, really. And we use them a lot in fractions today. Maybe we've seen these before in our algebra, but we could say that 3/4 is proportional or is equal to 15 over 20. And so how does that happen? How can we say it's a proportion? Well, because the same number that we multiplied 3 by to get 15, which is just 5, we multiply by 4 to get 20. So 3 times 5 is 15, 4 times 5 is 20. These two numbers that we multiplied are the same. I've got to get a new marker. Now that one's not working anymore. And so we could use the same logic if we're actually missing a number. Say let's say we have a ratio of 4 to 3 is equal to 5 to k. We don't know what k is. Well, we could say, what number do we multiply 4 by to get 5? We'd multiply whatever that number ended up being. We'd multiply 3 by that number to get k. Well, in this case, it's not as easy as it looks, because there's not a simple way to, in our minds, quickly to say 4 times what equals 5. Now, you may be able to catch on and do that math in your head, but most people, most of us can't. So there's an easier way to do that. If you have a proportion set up and you're missing a number, or there's a variable there, or you happen to find that number, we can simply cross multiply. I remember doing that from I guess way back in grade school. We learned to cross multiply, maybe in general math, maybe in 7th grade, 8th grade. But anyway, we'd say 4 times k, or 4k, is equal to 3 times 5, which is 15. And now our basic algebra tells us to solve for k, just divide by 4 on both sides. Of course, the 4's cancel here, and k is going to be 15 over 4. And so another easy way to solve or to use those proportions. All right, so we're going to jump into another type or problem using some proportions, some ratios, and some proportions. So we'll see how they work with these actual problems that we're going to do. Okay, so let's look at 18.1. It says the ratio of Arabians to mixed breeds in the herd was 2 to 17. And if there were 380 horses in the herd, how many were Arabians? Love horses. Arabians, beautiful, beautiful horse. I'd love to have a herd of horses, especially with Arabians. I just don't have that kind of time, money, or land to have those. But we can always dream about that. But let's talk about this. We said Arabians were what? First off, we're going to talk about just the ratio that we have. The ratio of Arabians to mixed. And so we had 2, our book says, to 17. That's the ratio of Arabians to mixed. Now our total, we're going to have to know, and we'll show you why here in just a second, but our total is going to be 19. How do I know my total is 19? 2 plus 17 gives me 19. All right, so here's why I have to know that. Because what we've done right here is simply got ratios from Arabians to mixed to total. And it says, okay, this is just a ratio because it's just giving us an idea of how they're mixed. But it says we have a total of 380 horses, and it wants to know how many were Arabians. Okay, so if we have 380 total horses, it wants to know how many were Arabians. Well, we'd have to use a ratio that we know both numbers in order to find out Arabians to the total that we have. What's a ratio we could write for Arabians to the total that we have in the herd? Well, we know our Arabians are 2. The total that we have in the herd is 19. Now recall, this is not the actual number in the herd. This is just, it means for every 2 Arabians, there's 17 mixed, and so we have a total of 19. And so our Arabians to total is 2 to 19, and we're looking for the Arabians if we have 380. So how are we going to figure that out? Well, we'll do the same thing we did before. We'll take 2 times, we're going to cross multiply, 2 times 380, which is 760, equals 19A, or 19 Arabians. And from there, what do? We just divide by 19. Then we can say that A equals what? Well, it equals 40. So there's 40 Arabians total in our herd. And so that's just a simple way to use ratios in order to solve a problem like that. Let's look at 18.2. 18.2 gives us another example how to do this. It says, I'll read it to you, it took 600 kilograms of sulfur to make 3,000 kilograms of a new compound. How many kilograms of the other materials would be required to make 4,000 kilograms of a new compound? And I'm just realizing, don't crucify me for this, but I misspelled sulfur. I'm gonna put my U in there instead of E. All right, how much sulfur did we use? Our book says that we used 600 kilograms of sulfur, and we had a total where that sulfur made 3,000 kilograms of a new product. Okay, and of course the other product we had to have, if 600 made 3,000 kilograms, well then the other product or the other reactant or whatever was used was 2,400 kilograms. Okay, so now they're saying we want to make 4,000 kilograms. What are we going to do? Well, we're going to put 4,000 down here, but it's asking how much of the other materials would need to be used. Well, the other materials, I'm just going to mark as O. That's kind of dangerous because a lot of times we can look at O and think it's 0, so you just need to be careful with that. Let's use our ratio. So we have 2,400 others to total 3,000. How much of the other product can make 4,000? So again, a quick ratio we'll do there. And those are some big numbers. We can say 2,400, our book shows us, times 4,000 equals 3,000. I'm just going to say OM for other material. And we won't show you the long drawn out, but the other material is going to equal 3,200 kilograms. After you multiplied these out and then divided it by 3,000. And so again, just a quick way to use ratios here. We're going to jump on over into our next section here and look at similar triangles, and it kind of uses the same material. What is a similar triangle? A similar triangle is two triangles that have the same shape. They look alike. They have the same ratio measurement of angles here. And so these are similar triangles. And since they're similar triangles, we can actually work between the two triangles to find some missing parts if we need to. Now the easiest way to do this really is to find the side. Now we'll just number this side 1, 2, and 3 based on the hash marks that are in the angles, and this is 1, 2, and 3. We need to find the side where both, or between the two triangles, that both of those sides is known. Well, it's the side between 1 and 3. Here is 4, but the side between 1 and 3 here is 3. I know it may be hard to see my little numbers there, but we can just see that both of these sides are known. And so 4 and 3. Well, what does that mean? That means I can say that 4 times some scale factor that I don't know yet equals 3. So 4 times some scale factor is going to equal 3. Okay, so once I find that scale factor, I can use it for the other sides. Now, I can just use that SF, that scale factor, as a variable. I can divide by 4 on both sides. And my scale factor now is 3 over 4. Found it. And so now once I find that 3 over 4, I can just multiply by every other side. 7 times 3 over 4 equals 21 over 4. That's y. Then I can say 5 times that scale factor, 3 over 4, is 15 over 4. That equals my x. So once I find that scale factor, it's pretty easy to find. I can also do it another way. We'll show you real quick. I could say that 4 is to 7 what 3 is to y. How does that help me? Cross multiply. 7 times 3 is 21 equals 4y. To get y by itself, divide by 4 on both sides. I get y equals 21 over 4. Hopefully that kind of made that a little easier, clear. You can use either one of those ways that you wish, but I would stick with the scale factor. Seems to be the easiest. Of course, in our ratio problems here, I hope those are simple enough for you. As always, if you have any questions, any problems, let me know. I'll be glad to help you out when I can.